Hello everyone. Let us continue the numerical problems on continuous beam. So this is the next problem. Analyze the continuous beam shown in figure. If the supports B and C sink by 3 mm and 5 mm respectively. For the beam, take I moment of inertia 4 into 10 to the 7 mm ratio 4 and Young's modulus 200 kN per mm square. So this beam is not carrying any load. So it is of uniform cross section, that is moment of inertia is 4 into 10 to the 7. So let's open the Staad Pro software by double clicking. So click on new project. Next, select plane. Next, you give the name as continuous beam. This is sixth problem, and the location you check it once, and the unit they are in meter and kilometer. Click on next. Next, add beam. Click on finish. So next, you select the front view. So the total span length is 4 plus 4 plus 6, that is 14 meter. So here the grid length is 10 meter. So you increase the grid length 12, 13, 14. So the grid length is 14 meter. Okay. Next span length is first is 4, second one is 4 meter, the third one is 6 meter. So first click on 0, it will create a node here. Next you click on 4 meter. Next you click on 8. Next on 14th node. Next you click on close. If you want to see the dimension, you click on the dimension here, display to the view, display. See here, 4, 4 and 6. If you want to remove, click on remove, remove. Now this is a line with 4 nodes. So you have to assign the property for this one. That is moment of inertia you have to assign. You click on general. Next click on define. Next here, earlier you used to give the depth and breadth, but here he has given the moment of inertia. You click on general. Here the moment of inertia Z is there. So here moment of inertia is 4 into 10 raised to 7 mm raised to 4. The yesterday uh, we have in the previous video we have seen the how to convert the mm raised to 4 to the meter raised to 4. So the same I will substitute the value Iz 0. It is 0.00004. So the material is concrete. Add. Next is close. If you want to assign this one to the whole beam, this is the beam cursor. You can select the whole beam. Okay, assign to the selected beams. Click on assign. Yes, now it is assigned to the whole beam. Uniform moment of inertia. So if you want to see the node, press Shift N. This is the node number 1, 2, 3, 4. So now it is assigned with the number. Next you have to here the in this problem there is no load. So but the support B and first let us assign the supports here. This is fixed and this is pinned. So let us go for support. Create the fixed support. Add. Next create the pinned support. Add. Select the fixed support. Click on assign. Take it and assign at the first node and fourth node. Next select the pinned support. Click on second node and the third node. Next you click on close. So as there is no loads on this one, so only the support sinking he has got. B and C sink by 3 mm and 5 mm. So it will. So you click on loads and load combinations. Here click on load case details. Add. So you give the name as load case 1. Okay. Close. Next you select load case 1. Click on add. Next here nodal load. And the support is displaying vertically down. So what is the value? It is 3 mm and 5 mm. So it is negative because it is acting downward. 0.0003 mm along y-axis. Add this one. Next is 0.005. Add, close. So it is the vertical displacement. 3 mm and 5 mm. So select this one. Use cursor to assign, take it and assign to the second node. Select this one. Already assigning is there. Select and click on the third node. Next is close. So next step is analysis and print. No print. Click on add. So it will ask for perform analysis. Go and click on the analysis. On analysis, it will ask for save. Click on save. So error should be 0. So 0 error is there. Next click on go to post processing mode. Done. Select the lowercase one. Okay. So first let us verify the bending moment. So click on the bending moment and tick the deflection. So you increase the scale by holding the control button and rotate the cursor up. So this is the bending moment diagram. So let us see the value. Reverse view value, beam results, bending at ends. If you want midpoint, you can see midpoint of loss. So let us verify the values. So here I have done a mistake here. So what the mistake I have done is I have not changed the modulus of elasticity. So I didn't change the modulus of elasticity. So modulus of elasticity 200 kN per mm square is there. So and again I will click on modeling. So I'll change the modulus of elasticity. Click on Staad editor. So here Young's modulus. This is 2 into 10 raised to 8. We have in the previous video I have shown how to convert the kilometer per mm square to no kilometer per meter square. So save it by Control S on the keyboard. Next you click on close. So now the modulus of elasticity has been changed. Next we click on analysis bar print. Click on add, close. Next run analysis. So 0 error is there. Go to post processing mode. Done. So lowercase 1. Okay. So let us see the bending moment now. So this is the bending moment diagram. So let us see the value. Results, hands, and midpoint close. Now this is at the end here 4.89 is there. So 4.892 here 5.712 is there. This is 5.709. At the support is 4.754 is there. Here 4.757. So it is correct. So similarly you can view the shear force Fy, control and scroll the button upward. So this is the shear force diagram. Let us view the results, view value, beam results, untick this one and click on shear at ends and midpoint, annotate, close. This is the shear force diagram. Similarly, if you want deflection, so click on the deflection, control, scroll the cursor upward. This is the deflection made by the beam. Results, view value, beam results, untick this one and click on the displacement, annotate, close. So here 3 mm is the deflection. The maximum is at this point, and at this support is some more 5 mm is there at this support. Next, you know how to take the picture, edit, copy picture, open the paint. Next, Control V, and save this one. File, save as JPG. You save wherever you want. Next, similarly, you can take the picture of the bending moment diagram. Similarly, I will take this one also. So this is the bending moment diagram. Edit, copy picture, open paint. Next, again you press Ctrl V on the keyboard. So this is the bending moment diagram. Next, shear force diagram also. Click on shear force. One tick this one. Shear force button is on now. Take copy picture. Again, open paint. Control V. So you can save this one also. So now let us go for the next problem. So this is our next problem. Analyze the continuous beam shown in figure. Draw also bending moment diagram and shear force diagram. So AB is one beam, BC is one beam. AB beam is 6 meter and BC is 4 meter. So again, here only click on file, new, plane. So this is continuous beam. I think this is 7 problem, 7th one. So choose front view. So the total span length is 6 plus 4 is 10. So the grid length is 10 meter. So it is no problem. Is no problem. So click on 0 first. Next click on the node. Next is 10th node. Next click on close. So now this is 6. This is 4. So here he has not given the any moment of inertia or the specification of the cross section of the beam. So you can assume any breadth and depth for the beam. So next is click on general. So you define the cross section for the beam. So assume 0.4, 0.35. Click on the material concrete. Next click on add, close. So let us assign the same. So already beam cursor is on. Select the beam. Assign to the selected beams. Click on assign. Assign. Next I will press Shift N to see the node numbers. Next click on support. So supports are fixed and this is pinned. Create, fix, add, create, pinned, add. Let's select this one. Fixed. Use cursor to assign. Assign here and this one. Next, this roller. Sorry, the pinned support. Second node. Next is click on close. So next here, one moment is the concentrated moment at 4 meter distance from the node A, and when UDL is there, that is 30 acting downward, very minus. So you click on loads and load definitions, click on load case details, add, give the name load case 1, add, close, click on load case 1, click on add. So watching number load I will, that is minus 30 kilometer per meter, it is acting over whole length. So along global y-axis, click on add. So it is added. Next, concentrated movement. So it is clockwise is there plus so it is 180 kilometer, but here you have to assume minus 180 to show to make it as clockwise here. So it is at a distance here. This D1. What is the D1 here? So this is the D1 4 meter. At 4 meter distance it is away. D1 is 4 global y. So it is acting along global z axis. Add, close. So assign this one. Uniform distributed load, use cursor to assign this one. Next this one. So you are unable to see the movement. Already it is assigned here. Okay, delete that one. Let us again assign. So once again, lowercase one, add member node, concentrated movement minus 180. The distance is given is 4 meter. Global z axis, add, close, select this one, use cursor to assign, click on this one. Now you are unable to see the movement. So you have to increase the scale for that one. Click on the mouse, click on labels. So here you can also check the load values. Next, you click on scales. So here you can see the point force, point movement is there. So you increase the point movement value. So I'll increase by some 70. Let me see, apply, close. Still it is bigger. So you can see the clockwise rotation. So again, it has increases on labels, scales. So I'll increase by 100, apply. So it is still more. But let me give 200, apply. 300 I will. Now you can see this is 180 kilometer. It is acting at 4 meter distance away. I'm not sure. So it will ask every time for say. So this is 30. This is 180 kilometer per meter. 180 kilometer meter. Now everything is assigned. Next, you have to analyze this one. Analysis by print. No print. Click on add. Close. Analyze. Run analysis. Click on save. Next, click on go to professional mode. Click on done. Lowercase one. Okay. So let us first verify by seeing the bending moment. This is the bending moment diagram. Let us view the results value, beam results, bending against point. Okay, close. So this is the bending moment value. So let me verify this one. So here it is 51.7 is there. Here 52 is there. So it is acceptable. Plus or minus 5%. Any software is acceptable. This is 26 is there here. This is 26. And here it is 16, 16. So this is correct. This is also 68 is there here. This is 67.98. So it is correct. At this point, we were unable to see the value. So this point, so these points it is not showing value. It is showing only at the midpoint here. So it is correct. So next, you can see the deflection. Press control and scroll the cursor. So this beam will bend upward, and this beam will make sagging. This is hogging. So you can see the bending moment values because this movement is rotating and it is pushing the. So this is pushing the beam upward like this. Is making an upward move, upward rotation, and this load it is making this beam sag. So next you can view the results, deflection results, view value, beam results, and take this one, displacement, annotate, close. So here the maximum deflection is there. So when it deflects upward, you should provide the, remember this one, when it is hogging, always you should provide the main reinforcement, the beam at the top. When the beam is sagging, you have to provide the main reinforcement at the bottom. This is just an example I'm showing. So you have to provide the main beam at the top for the hogging, main reinforcement for the hogging, and at the bottom for the tagging. So similarly, you can view the shear force diagram, results, V value, beam results, shear attempts, midpoint, annotate those. So let us see the value here. The shear force diagram is also there. This is 68.898 is there. This is 69 is there, and here this is 51.0 is there. This is 51.1 is there. This is 44. This is 44 is there. So it is correct. So let us end the class. We will continue some more numericals in the next class.